3. We left off, right? We talked about positive products and quotients, negative products and quotients, right? Maybe ringing a few bells? Okay. Thanks for the feedback. All right, so remember, if we're multiplying two things that are the same sign or dividing two things that are the same sign, we'll get the positive product or quotient, and if they have different signs, negative product and quotient. If we add in more numbers to multiply, then we have to keep applying that rule every time we add in something new. So like example D on the multiply side, we had a positive product, and then when we multiply by -1, it becomes negative, but then when we multiply by -2, it becomes positive again. So we have to reapply the rule every time we have more than two numbers as part of our product and our quotient. All right. Other than that, I'm fairly confident that you guys know how to multiply and divide for the most part. Just making sure that you're getting the correct signs for your. And again, a lot of this can go in your calculator as well, but you need to make sure you understand that process so that you know if your answer makes sense or not. All right. These are a couple just kind of properties to kind of go over and be aware of with our real numbers. We talked about these a little bit, so I just wanted to elaborate. The zero multiplication property, if we multiply anything by 0, it equals 0. All right, anything times 0 equals 0. Jumping down to quotients, anything divided by 0 is undefined, but 0 divided by anything is always 0. Okay, so 0 is this natural number that likes to not be anything other than 0. And then reciprocals play in, of course, when we're doing our division. The product of two reciprocals is always 1. Just as a kind of a refresher, for reciprocals, if I have -3/4, what is it? What is -3/4 reciprocal? Close. Keep the negative. Okay. Don't want to change the sign. We want to keep the negative. Okay. And again, that negative could be up there. Or the negative could be down here, or the negative could be out front. Those are all equivalent fractions, as long as you have the negative somewhere in that fraction, but not on both. Okay. What's the reciprocal of 6? 1/6. 1/6 is our reciprocal. Okay. Products are always 1. Reciprocals are used when we divide fractions. Okay? It's also used in a lot of other more complicated procedures that we'll see later in the year. So those are those properties there. All right. So now we're going to move into our outside of our basic arithmetic into our exponents. Okay. So again, A is a real number, N is a natural number. The N as a natural number is a really important part. Okay. That we're dealing with a natural number, because if we're using an integer or a real number, then the process gets way more complicated. We'll have those later, but not right now. Okay, so we're going to focus on our nice easy exponent, where our exponent is a natural number, 1, 2, 3, 4, 5, any of those, okay, and so on and so forth. Exponents are just repeated multiplication. We have our base and we have our exponent. The base is a thing that gets multiplied over and over and over and over again. The exponent says, how many times am I going to do that process? Okay, so here we have 3 to the 4th power is 3 times 3 times 3 times 3. Okay, 3 is my base, 4 is my exponent. I'm multiplying 3 by itself 4 times. 3 is a factor 4 times. Okay, so I want you to look and what is the expansion of 1/3 to the 3rd power? Which of these options is the expansion of 1/3 to the 3rd power? Okay, so 1/3 times 1/3 times 1/3. Perfect, you guys are so smart. Okay, All right, so now we want to evaluate, and we want to look at beyond just the expansion, but also being able to evaluate a lot of these. And some of these you want to be able to do rather quickly. When we're dealing with exponents, specifically squares and cubes, there's a few numbers that you're going to see a lot. So being able to kind of memorize those is going to speed up and make your life a whole lot easier. Okay? So if I have 3 to the 4th, I've got 3, how many times? 4 times. Okay? So 3 is a factor 4 times. Okay? 3 times 3 times 3 times 3. Okay? So when we evaluate that, I can do it in chunks. Okay? Commutative property of multiplication so that I can multiply in any order. So what's 3 times 3? 9. So I end up with 9 times 9 to give me what? 81. Easy peasy. Right? Okay? We expanded 1/3, 1/3, 1/3. So those are being multiplied together. Okay? So multiply our numerators. What's 1 times 1 times 1? 1. What's 3 times 3 times 3? 27. So 1/3 cubed is 127. Okay, 127. All right, now C and D is kind of a big point of contention that causes some stumbles. Okay, parentheses are there for a reason. All right. So what I want to note here is a couple different things. So remember, we have a number raised to a power. Okay. The number raised to the power is our base. Okay, the number raised to the power is our base. Here, my base is 6. Here, my base is -5. What's the difference to determine that? Okay, so one of my bases is negative and one of my bases is positive, but both of these expressions have a negative number raised to a power. So why does this one have a positive base and this one have a negative base? It's on the -5. Because of the parentheses creating the grouping, this entire expression with the negative included is my base. But on C, I don't have that indication. So that negative is not part of the base. So this is more accurately that. Okay? Or we can expand it to -6 times 6. Okay? -6 times 6 versus -5 times -5. All right? Notice the difference there. It's going to show up a lot. Like a lot. Pretty much all through the year, okay? You're going to see that annotation, and it's never going away, all right? So make sure early on you recognize the difference between -6 squared versus quantity of -5 squared, all right? So 6 times 6 gives me what? 36, and this is going to be a negative solution because I have that negative left over. But -5 times -5 gives me positive 25. Okay, positive 25. So notice the difference between those. Questions, comments, concerns on that, especially with those negative bases. Okay. All right, square roots. So we'll be doing a lot of things with square roots. And depending on the situation, we have to kind of interpret them in a couple different ways. Understanding the relationship between squaring and square roots. They are opposites. They are inverses. Just as much as addition is the inverse of subtraction, division is the inverse of multiplication. Square roots is the inverse of squaring. Cube roots is the inverse of cubing. Okay? Roots and exponents are inverse operations. So when we have a square root, essentially we kind of have to think backwards and say, okay, well, what number times itself gives me this value? All right, and we look back at the last one, and we had -5. If I can write, that'd be smart. All right, I had -5 times -5, right, and that gave me 25. -5 times -5 gave me 25. which means I could work backwards and say, well, the square root of 25 is negative 5, right? I should be able to go backwards and forwards. But there's another number when squared that also equals 25. What is it? Positive 5, right? So the square root of 25 is also positive 5. So we have to have a way to differentiate between the two. Which answer do we want? It depends on the scenario. For now, I'm going to tell you. We have what's called the principal square root and the negative square root. And it's going to want whichever one based on whether or not there is a negative sign in the front. So if I want the square root of 25, but I want the negative square root, then I need to write it as let's see if I can fit it there. There we go. Wow, that's going to be pretty awesome. Okay, we need to write it as the negative square root. Okay, so the negative square root of 25 is going to be negative 5, and the principal square root of 25 is going to be 5. So we're going to indicate whether we want the principal or the negative. All right, the problem will tell you. When we get into equations and solving equations, we have to make a little bit of a variation on it because there'll be some stuff that goes with that later. But for now, I'm going to tell you which one I want. All right? So you need to know your square roots at least up to 12 squared, okay? 12 squared is 144. So you need to know from 144 down so that when you see the common perfect squares, it doesn't take you too long. You're not wasting your time trying to fill it in a calculator, okay? So what is the principal square root of 49? 7, okay? Because it wants the principal square root, I'm only going to include 7. When we have fractions, we can, under a radical, we can square root both the numerator and the denominator. Okay, so I can look, well, what's the square root of 25? 5. What's the square root of 16? 4. Okay, so my answer is 5/4. What's the negative square root of 4? Negative 2. Okay. What's the square root of negative 25? Nope. It's not real. Okay? So I can't multiply 5 times 5 to get negative 25. I can't multiply negative 5 times negative 5 to get negative 25 because they have the same. There's no number that can be squared to give me a negative value. No number squared gives me a negative value. At least no real one. And so this, for now, is non-real. We'll deal with non-real numbers later in the year. That's like fourth quarter stuff. Okay? But for now, we're sticking with this as non-real because that's the section we're in, is the real number system. Okay? So yes, there are non-real numbers, and we will do very real math with them. Okay? But for now, we're sticking with the real values, and there is no real value for the square root of negative 25 or any negative number for that. Okay? So we're going to leave that as non-real. Questions, comments, concerns, queries? So lively, barely contain it. All right. Order of operations is a super duper fun thing. I swear it's like every 6 about order of operations, and it drives me insane. One of the reasons that we request a specific calculator, specifically a Texas Instrument, many reasons, but one of them is consistency in the order of operations. Because you will find calculators calculate things if they're programming. And they make certain assumptions. It's kind of weird, right? You plug something in a calculator, you think it's going to be consistent no matter what calculator you use, but that's not always the case. Okay? And one of the biggest issues comes in with expressions like, say, I had, just making up numbers, 4 plus 6 parentheses 2 plus 1. Okay? Some calculators will calculate that differently. You'll get 2 different, okay? Because there's programming differences. And they make an assumption. Some calculators will assume a fraction when there is or is not necessarily one. Okay, so it makes it difficult when you just rely on your calculator entirely for something. You plug it all in and then you get something that you don't expect. Okay, it's just the nature of the world, unfortunately. So we have the order of operations. Is this law that's been around for just God knows how long to create a consistency. And that order is that first we start with groups. Okay? Parentheses. Absolute value. Square roots. Okay? We evaluate anything that's in a group first. The second thing is that we go through and we have exponents. We need to make sure that we actually evaluate the radical if we can. Once we get rid of those higher order functions, then we go down to the multiplication and division. And here's one of the biggest mistakes a lot of people make is that they assume you have to do multiplication first, then division. Okay? You don't. You do them at the same time. They're the same step from left to right. So it doesn't matter if you see division first or multiplication first, or it goes back and forth between the two in a really long expression. You go from left to right, take care of all your multiplication and division, and then once all of that's done, then you're going to end with your addition and your subtraction. Okay. Some of you there's a couple different acronyms. You've got PEMDAS, PEMDAS. I know some European countries use GEMDAS instead. Grouping. Which I think makes a little bit more sense because P is parentheses, but we have more groupings than just parentheses because absolute value needs to be done first before exponents are done. Okay, same thing with if you have operations inside of a radical expression. If you have something being raised to a power, but it's inside of a grouping. Fractions are groupings. A numerator can have multiple operations in it. You have to do those first before you can do the division of the fraction. And so we're going to use our order of operations, and we're going to go through a couple different examples. All right? So first one, nice and easy. I've got 30 divided by 5 times 3. What's my first operation that I'm going to do there? Division. Remember, multiplication and division are a unit. They're done together from left to right. So even though there's multiplication in there, the division shows up first. So we have to do that first. Okay? The division shows up first, so we have to do that first. So we're going to do the 30 divided by 5 to get what? 6. And then I have my 6 times 3, 18. Okay? If we did it in a different order, we'd get a very different answer. Okay, so it's really important that we follow that order. If I did the multiplication first, I'd get an answer of 2. All right, not 2. The answer is 18. All right? B. We have a fraction here. Okay? We have a fraction. And when you have a fraction, your numerator and your denominator are considered a grouping. There's like imaginary parentheses around there. So before we can simplify the fraction as its entirety, we have to simplify the numerator and simplify the denominator first. If it makes it easier, you can write them separately and then put them back when you're done, or you can try and simplify them at once. I'm just going to split them up. I'm going to say, okay, so I've got the absolute value of 3 cubed. 3 cubed. Maybe I can write a cubed. There we go. Plus 2. And then I also have my denominator. That is negative 6 minus the square root of 9. So I'm going to work both of these, and that's going to be my numerator and denominator for what I'm going to simplify. Okay? So looking at what's in red, what's the first thing I'm going to do here? Before the exponent, I'm going to do the absolute value. Okay? I have to evaluate that absolute value first before I do the exponent. Okay? The groupings first, then the exponents. So what's the absolute value of 3? Or negative 3? 3. So I have 3 cubed. Really doesn't want me to write those 3's. Apparently it thinks I want a backwards C. Plus 2. Now, 3 cubed is what? 27 plus 2. 29. Okay? All right, I skipped that step because I was running over. Okay, 27 plus 2. Questions on that part? You good? Okay. All right, what's the first thing I'm going to do on the right? Square root of 9 is what? 3. Negative 6 minus 3. Negative 6 minus 3. Okay, so numerator, denominator, so my final solution, 29 over 9. And you could either do that, or that, or that. Doesn't matter which one. That's my preferred method. Usually I don't like having a negative in the denominator. It just looks weird. Okay, so that. I can't simplify 29 over 9. They don't have a common factor, so is it pretty? No. Is it our answer? Yes. Okay. I'm going to have you guys do C, and then we're going to come back to D. Okay? All right. Work from your innermost groupings out. Innermost groupings out. All right. There's a lot going on here. That's fine. What's the first thing that I need to simplify? Okay. So I've got parentheses and I got brackets. So I got to work on the inside first. So the parentheses, 5 minus 7, and 6 minus 10. What's 5 minus 7? Okay. And then I've still got this. Still got that. Still have this, and then 6 minus 10. Negative 4. Okay, so I still have that bigger grouping. I left the negative 4 in parentheses so that remember it's multiplication, it's not subtraction. Okay, so now I'm still focused in this big grouping here. So what's the next thing that I need to do? I have negative 2 plus 2 times negative 4. Okay, so 3 minus negative 2 plus negative 8. Okay? All right, now what?
I will do negative 8 minus 2. It will be negative 10.
So 3 minus, we add these together, so negative 2 plus negative 8 is negative 10. And 3 minus negative 10 becomes 3 plus 10. 3 plus 10 to get 30. Alright, so there's a lot. But you just need to take it step by step, and you got to pay really close attention to those negatives. Pay really close, because they'll trip you up in a heartbeat. Pay really close attention to those negatives, especially when we have some extra subtraction in there. Okay, we've got that multiplication in there. Pay really close attention to those negatives. All right? 13. All right, let's look at D, and then we got one more slide after that. We're not doing 26 because that snuck in from tomorrow's. So, again, big expression. Take it piece by piece. All right? Let's focus on just the numerator first. -5 times the square root of 30 minus 5 plus -2 cubed. What's the first part of that numerator that I should simplify? I should simplify the root. Specifically, the subtraction inside the root. 30 minus 5 gives me what? 25. Okay? So I have -5 square root 25 plus -2 cubed. Okay? Now, what's the next thing that I can do? Square root of 25. All right, and just to speed up the process a little bit, I've got this other operation that's going to come next, so let's go ahead and do that too. So, square root of 25 is 5. Let's go ahead and do -2 cubed. What's -2 cubed?
It's negative. But sir, wouldn't it be like the root of 25? It's going to be 5.
This right here is multiplication. So -5 times 5. So we got -8 here. Okay? Yeah, when there's no operation symbol between two objects, it's assumed to be multiplication. All right? Next thing in the numerator. Multiplication. -5 times 5 is 25. And then we have, so -25 plus -8 gives me what? Okay, am I done? No, what am I missing? The denominator. Okay, so now we got to do the denominator. All right, so there's my numerator. And then let's go back to red. Okay, so first thing to simplify in the denominator. Okay, 7 minus 10 is what? -3. So 4 squared plus the absolute value of -3. What's the absolute value of -3? 3. 4 squared plus 3. What's 4 squared? 16 plus 3. 16 plus 3 equals 19. So what's my final answer going to be? If I could simplify the fraction, I would, but I can't. So, that's about as bad as it'll get. So if you can do that, if you can work through that kind of step by step and just take it piece by piece, didn't have that much of an issue with order of operations. Okay? Questions on that before we do the last thing real quick? We did a little bit of this earlier in the chapter, just kind of do a quick refresher now that we've got the order of operations in. So evaluating algebraic expressions, I've got x equals 5 and y equals -2, so I want to plug them in and evaluate these expressions, okay? So 4 times what? 4 times 5 minus 5 times what? -2. And again, pay really close attention. I've got a minus, and I've got this negative and this multiplication. So be very, very careful while you're working that out and pay attention to your signs. Okay? Which one am I going to do first? Multiplication. 4 times 5. 20. Okay? So I'm just going up here. All right. 20 minus 5 times -2. There you go. Okay, 5 minus -10. And so now I've got 20 minus -10, which is 20 plus 10, which is 30. Okay? -3 times what? -2 squared. Now, again, we have those exponents and those bases. Y is our base and y is -2. So that means -2 is the base of the exponent. So it needs to be in that front to indicate that -2 is the base. What's the first operation to do? Not multiplication. The exponent, the square. So negative 3 times, what's negative 2 squared? 4. Positive 4. Positive 4. Negative 3 times 4 gives me negative 12. Okay? And also something that I want to point out, because I always get the question. All right? Say example A wasn't here. It just says, evaluate each expression when x equals 5 and y equals negative 2. Is there an x in this expression? No, and that's fine. It doesn't have to be. Okay? Sometimes they'll throw in extra variables. You just won't use them. So you have to know which number you're going to plug in where. Okay? So don't overthink it. Be like, there's no x. What do I do with the x? Nothing. Don't do anything with it. You don't need it. Okay? Questions, comments, concerns? Woo! Day 4 down. We did it. Cool. Okay? Got about 5 minutes left if you want to keep working on your homework. You should be, you should have started it yesterday, I hope, for your sake. But remember, we have all of 1-3 now, so it is due tomorrow by the beginning of class. Okay? So before you come to class, your homework needs to be uploaded. Okay?
It's for 1.3.
I have some people that already submitted it, which is fine. Not a big deal.